Hello, d minus 1 to the power of 4 is equals to 4 to the power of 4. How do we solve for the solution? Let's get down the question first. We have d minus 1 to the power of 4 equal to 4 to the power of 4. This left hand side could be written as d minus 1 all squared times 2 equal to the right hand side also could be written as 4 square times 2. Let's continue. This implies that now let us move this right hand side to the left hand side. So that will be d minus 1 all squared times 2 minus 4 squared times 2 equal to 0. At this stage, let us recall the difference of 2 square. It says a square minus b square is equal to a plus b times a minus b. Take note of this identity, very important. Now, let's apply this identity to the left hand side. Doing that, we are going to have d minus 1 all squared plus what is b? B is 4 square. So we put that in brackets times a now. A is d minus 1 all squared. That's our a. So we have d minus 1 all squared minus what is b? B is simply 4 square. So we have 4 square, everything equal to 0. Let's continue. This implies that if you expand d minus 1 all square very well, you're going to have d square minus 2d plus 1 plus what is 4 square? That is 4 times 4, 16. Close bracket times. Expanding this also very well, we have d square minus 2d plus 1 minus what is 4 square? That is 4 times 4, 16 equal to 0. Let's continue. This means that d square minus 2d plus 1 plus 16, that is 17, times d square minus 2d, 1 minus 16, that is negative 15, equal to 0. Let's proceed further. This implies that d square minus 2d plus 17 is equal to 0, or d square minus 2d minus 15 is equal to 0. Now, let us solve each of these quadratic equations. Let's consider this guy first. We have d square minus 2d plus 17 equal to 0. We can actually solve this using quadratic formula, which is d equal to minus b plus or minus square root of b square minus 4 times a times c, all divided by 2a. From this equation, it is obvious our a is equals to 1, coefficient of d square, b is equals to minus 2, and c is equals to 17. Let's continue. So we have d equal to minus, what is b? B is negative 2, so we plug in that, plus or minus square root of b square, that will be negative 2 all squared minus 4. What is a? A is 1 and c is 17. So we have into 1 into 17, all divided by 2 into a. A is simply 1. So we have 1. This means that d is equal to minus times minus 2, that is 2, plus or minus square root of minus 2 all squared, that is positive 4, minus 4 times 1 times 17, that is 8, divided by 2 times 1, that is simply 2. Let's proceed further. So we have d equal to 2 plus or minus square root of 4 minus 68, that is negative 64, divided by 2. Let's proceed further. So we have d equal to 2 plus or minus, I can write square root of minus 64 as square root of 64 times square root of negative 1 divided by 2. Let's continue. So we have d equal to 2 plus or minus. What is square root of 64? That is simply 8. And don't forget, from the complex number, we know that square root of negative 1 is equals to I. So we have I here divided by 2. D is equals to, it is possible I can pull out 2 from this numerator. So that will be 2 into 1 plus or minus 4i divided by 2. This implies that D is equal to, clearly 2 cancels 2. We are left with 1 plus or minus 4i. This implies that D is equal to 1 plus 4i, or D is equals to, consider the negative sign, we have 1 minus 4i. You will notice that we have two complex solutions. Now, let's solve the other quadratic equation, which is this guy, d square minus 2d minus 15. So let's manage this side. We have d square minus 2d minus 15 equal to 0. If you look at this quadratic equation very well, you will notice that it is factorizable. We can factorize it. So let's factorize it. So that will be d square minus 2d could be written as minus 5d plus 3d minus 15 equal to 0. I can factor out d from these two guys. It is common. So that will be d into d minus 5. I can also factor out 3 from this guy. It is common. So I have 3 into d minus 5 equal to 0. This means that d minus 5 is common. So we have d minus 5 times d plus 3. D plus 3 equal to 0. Let's continue. This means that d minus 5 is either equal to 0 or d plus 3 is equals to 0. From this line, this guy, d is equals to 5. This is another solution. Or from this second line, d is equals to minus 3. This is another solution. Now, let us put down all the solutions that we have for this equation. Therefore, all the solutions that we have, the first one is d equals to, okay, let's do it this way. These are the two complex solutions we first obtained. We have 1 plus 4i. Let's call it d1. And d equals to this guy, 1 minus 4i. Let's call this d2. And the last solutions that we obtain, d equals to 5 and d equals to negative 3. So respectively, we have d3 equals to 5 and d4 is equals to negative 3. You will see that we have four distinct solutions. Four distinct solutions for this equation, two complex solutions and two real solutions.